Hi, everyone. Welcome to Dave's 10-Minute Tech Talks. This is a new series of short videos that I've been releasing on LinkedIn based on some of the content that I cover in the courses and the lectures that I give and the conferences I present at. So my name is David Goad. I've been in the industry for over 25 years to work for some large organizations like KPMG Consulting, Microsoft, and Hitachi Services Solutions. Currently, I work for the University of Sydney and the University of New South Wales, where I teach digital innovation and digital strategy. I have certifications from Microsoft AI and Google AI. I'm a co-chair of the IoT Association of Australia. And I spend most of my days either working with organizations, helping them with their AI and IoT strategy, or teaching courses or giving conference lectures with regards to these different types of technologies. So I'm going to release a couple of Tech Talk series. The first series that I'm going to release is going to be around artificial intelligence. There will be 3 videos in the series. There will be one around what is AI and what it is not. I'll then do a second video with regards to managing the risks of artificial intelligence and how you should handle those as an organization. And then I'll do another short video deploying AI in your organization and what are some of the lessons that I've learned over the last couple of years being an AI practitioner and also an AI researcher in the field. So this particular video is going to be about what is artificial intelligence or what is AI. And this question of what is AI is an interesting one. To be frank, when I deal with a lot of executives, CIOs, CTOs, and technologists in the industry, there's no real sort of consistent definition of what artificial intelligence is. And I think there's a lot of misunderstandings out there in terms of what artificial intelligence is and what is it not. So I'll try and dispel some of those misconceptions through the course. So what is artificial intelligence? Well, roughly speaking, it's sort of technology that follows sort of 3 key criteria. The first one is reasoning. So this is technology that can learn and draw conclusions from large volumes of imperfect data. We talk about the idea that there's been more data produced in the last 18 months than the whole history of man. Technologies like the Internet of Things and that are contributing to huge amounts of volumes of data. How do we as human individuals manage all this data? Artificial intelligence is one form. A second thing that artificial intelligence, the areas of artificial intelligence, is this issue of understanding or interpreting meaning in data. And so you see lots of examples of this, for example, in terms of Google Home or Alexa, Amazon Alexa, voice, image recognition, machine learning, machine vision, deep semantic similarity models in terms of doing voice recognition. These are another branch of artificial intelligence. And the third branch of artificial intelligence is using the technology to interact with people in sort of natural ways. For example, chatbots is a very popular technology these days, or conversational agents as they're called, for artificial intelligence. So these are all sort of common modes. But basically, AI is making machines respond and act more like human beings through reasoning, understanding, and interacting. So there's all kinds of different applications of artificial intelligence. Just a few examples so people can get an idea of how it's being used. For example, you have American Express, who processes over $1 trillion in transactions and 110 million Amex cards. They heavily rely on machine learning algorithms to, for example, detect fraud and to save money from millions of dollars a year in losses due to fraud or illegal use of credit cards. Probably one of the most interesting examples of AI that I've seen in recent years is this idea of machine vision in the medical industry. So the whole idea here is that machine vision, or AI that actually reads photographs or images, has actually become more accurate than human vision. So using these technologies to support radiologists and doctors in terms of their analysis of various photographs and diagnostic tools is becoming more and more popular. For example, in China, they're using it to augment radiologists doing CT scan evaluations. Then you have other examples, for example, John Deere using it to actually take a look at information with regards to crops and make decisions about when to treat a crop with specific pesticides. And then probably one of the ones that you guys are probably more familiar with is organizations like Netflix that are using AI and machine learning to essentially predict which shows or which movies or TV shows that you prefer. This technology has become so accurate now in terms of them identifying what your preferences are that they're actually eliminating the use of the pilot episode. So traditionally, Most production studios would do a pilot episode first just to test to see whether the concept was popular or not. Now you find that Netflix is simply eliminating the idea of a pilot episode and going straight to production based on the analysis from their artificial intelligence tools that use their big data that they collect about the people who use their service. And finally, you get some sort of novel or entertaining kind of uses of AI. For example, Barbie has been released. There's a talking Barbie now that uses AI to basically talk to the kids who use the Barbie doll. So there's all kinds of different examples: medical industry, finance, entertainment, toys, where you can see AI being used nearly almost every single. This whole sort of popularity of artificial intelligence has led Gartner to make a number of sort of strategic planning assumptions with regards to the use of artificial intelligence, and these are things that people should really be considering with regards to AI. For example, Gartner is forecasting that by 2020, 20% of students in developed nations will use AI assistants such as Google Home or Alexa to help them with an array of everyday operational tasks. By 2022, 1 in 5 workers engaged in mostly non-routine tasks will rely on AI to do their jobs. You also find a large percentage of CIOs piloting AI programs. Now, what this statistic doesn't speak to is how successful those AI programs are, but just about every CIO out there or CTO out there is trying to use artificial intelligence in their business. You're going to find that a lot of application development is now incorporating AI. The major players in terms of AI, like such as your Googles, your Amazons, and your Microsofts, are building technologies to make it easier to incorporate AI into your development activities. More than 50% of enterprises are expected to use some form of chatbot or conversational agent, and that to a point where it's actually going to be more common than just normal mobile app development. You're also going to see customer-facing employees using AI virtual support for decision and support analysis. So inbound call centers using AI to predict preferred products on the part of inbound customers to identify their problems and to help identify issues and responses to customers' inquiries. By 2022, half of the DNA services will be performed by machines. All indications that AI is definitely something that's taking off now in the last few years, and is something that's here to stay, and that a lot of organizations have to think about artificial intelligence. Now, there's a few things that I want to talk about in terms of what artificial intelligence is not. So there's this concept of narrow AI versus general AI. So let me define. General AI is like C-3PO in Star Wars or Data in Star Trek. This is where you're using artificial intelligence based on previous scenarios and applying it to completely new scenarios. So this is trying to make machines almost act entirely like human beings. Narrow AI is where you're using artificial intelligence for a very specific use case. For example, making a decision about a specific process, for example, a home loan application, or facilitating the interaction with someone through, say, a chatbot. The reality of it is, general AI is, at least depending on the analyst that you talk to, 25 to 30 years away. Narrow AI is here and now. So you guys, are all probably using narrow AI now in terms of, you've probably seen a chatbot, or you probably work with a Google Home or some other technology like that. Narrow AI is very much here and now. General AI is very much far away into the future. What this means for me is simply the fact that all these dire predictions about AI replacing people's jobs in their entirety in the near term are just simply not realistic. The technology is not there yet. Maybe in 25 to 30 years' time, but I don't think that AI is going to replace completely anyone's job right now. It may augment people's jobs. It may reduce the amount of manual transactions being processed in the near term. But this whole idea of general AI or having a machine completely replace a human being, I think is still a ways into the future. There's another misconception about what AI is and what is not, and that is, if you think about it, the whole benefit of AI is being able to process mass amounts of data very, very quickly. What that means is that you can provide very personalized services to people, your customers and people that you're dealing with. It's not about standardization or making the same decision all the time. It's actually more about providing personalized services based on more information. We as human beings can only process about 5 or 6 bits of information at one time. Machines don't have that limitation. Their ability to take a lot of information about us as human beings and then make predictions about what we prefer in terms of products or what our issues are, or to identify problems is much more powerful than the standard human being can support. Then there's this issue of intentional bias versus unintentional bias. One of the biggest complaints around supervised learning, and I'll talk in a minute about the types of AI, is the fact that there's this issue of unintentional bias. I'll give you an example. You use the artificial intelligence tool, for example, they've trained AIs to make decisions around home loans. One of the inputs they put into the home loan is, for example, postal code. What they realize is that postal code is a clear indication of race. So you've got an issue there where, because of the way the model's built based on the people's perceptions, the actual tool set has bias. This is that whole point that an artificial intelligence tool has to, supervised AI learns off its masters. If those masters already have a bias, or they unintentionally build bias into the tool, then the tool would be biased in and of itself. What people have to recognize is, in some cases, bias is not necessarily a bad thing. For example, if people are not financially solvent, then there should be a bias against them in terms of, for example, providing with them home loan. That being said, you got to be careful about unintentional bias, where you're, for example, prejudicing the person unfairly or whatever, where you don't realize that you're putting bias into the tool. So in not all cases is bias a bad thing. In not all cases would you have bias, because, for example, bias only applies to really one form of AI, which is supervised learning. But the issue that you get into is that unintentionally people put bias into these tools and they make wrong decisions based on that bias. And that is one of the challenges that you have to deal with. Now, a few definitions so people can kind of understand the differences, because there is a bit of confusion out there about what these terms mean. So the first general term that I use is what I refer to as algorithmic decision making. So this is the idea that you're using computer programs and computer software to automate the decision process. This has been around for years, basic sort of if-then statements or whatever in computers. If this happens, then do this. You see these all the time. Artificial intelligence, as I said, is a form of algorithmic decision making, and then it uses software code to detect various external factors and then takes actions in the environment through some form of automation. In so doing, AI mimics the natural intelligence displayed by human beings. So as I said to you previously, this can be in terms of reasoning, management, making the AI, making machines look and feel more like human beings. A form of AI, only one part of AI, is what they refer to as machine learning. This is a subset of artificial intelligence, and basically these are the mathematical models based on historical information that are used to construct or predict what the impact of a specific action the machine will take on its environment. You have to remember though, that these are about historical models, so that, no one can foresee into the future, and these models are very much dependent on the future being similar to the past in terms of how the models are built. When you build these mathematical models to represent, or in a format that looks similar to the human brain in terms of neurons, this is what is referred to as neural networks. The term neural network comes from the concept that the mathematical models are designed to represent the function of the human brain or neuron or brain cell. When I say represent, a lot of psychologists and doctors will get a little bit frustrated with this, because we may build a neural net which is similar to a human being, but it's nowhere near the complexity. I'll give you an example. When you're building a neural network for machine learning, for artificial intelligence, you put in what they call an activation function, or it's a nonlinear function, to basically determine when that neuron will fire. In most machine learning networks built these days, there's possibly one or two types of activation function used, or one or two types of nonlinearity. The human brain, so far, they've found at least 27. So to say that neural networks they are patterned after the human brain, but they're nowhere near as complex, at least in terms of the current technology, compared to the way the human brain works. And then you have this concept of deep learning, and this is this idea that you build neural networks that are very deep, that have a number of layers, and the idea is that these layers can represent complexities in terms of analysis and be able to analyze more and more complex sets of data. So why is AI, coming now? Years and years ago when I did my undergraduate in engineering, we talked about neural networks and artificial intelligence, but it seems to really be picking up over the last sort of 5 or 10 years, and there's a few reasons for this. The first reason is improved sensors or telemetry. This is basically the concept of the Internet of Things, the fact that we're collecting way more data now than we ever have in the past. The other issue is that you have this availability with cloud computing of massive on-demand parallel compute and storage, which can be used for short periods of time and then turned off. One of the challenges with these AI models traditionally has been that they're hugely complex and take a lot of computational effort to be able to build. Now that you have the cloud and you essentially have unlimited computational capabilities, you can now build very, very complex AI models which are closer to representing how humans think. And the other reason why AI is becoming popular now is just simply because of the fact that the mathematics behind artificial intelligence has just improved dramatically over the last few years. And I illustrate this with two graphs here. So one of the ways that you can tell the progress of artificial intelligence is that every year the specialists in AI have these sort of international competitions where they compete against each other to build the best AI tools to do specific tasks. One of these is referred to as ImageNet, where every year machine learning specialists or data scientists compete to see whether they can build a machine learning algorithm that's really, really good at recognizing photographs. So if you look at the statistics, this is the chart in the top right, where you can see this sort of object recognition and talks about the error rate based on the ImageNet competition that happens every year. What you see is in the last 2 to 3 years, the ImageNet competition is actually producing machine learning algorithms or artificial intelligence that's actually more accurate than a human being. The average human being has an error rate of about 5% when reading a picture. These new machine learning tools with regards to machine vision are actually more accurate human beings. You see a little bit, not as rapid progress recently in terms of, for example, human speech recognition. So the chart on the bottom right shows the progress in terms of competitions with regards to word error rate with regards to speech recognition. Not quite as accurate as human beings. That's why if you're using your Google Home or your Amazon Alexa, sometimes they ask you to ask them what you want twice. Speech recognition is probably a little bit behind, say, machine vision. But the point here is that there's been a dramatic increase or improvement in terms of the mathematical models in the last few years, which has contributed to the why AI is becoming popular now. You add all these three things together, the improved sensors and telemetry, the massive capabilities in terms of on-demand parallel storage, and these new mathematical models, and you effectively get cost-effective human-like decision-making available here and now for narrow applications. Again, general AI, where you have a computer that's being able to think like a human being across a variety of different scenarios, is way off into the future, but certainly in terms of narrow AI, the model. What are some of the advantages of machine learning and artificial intelligence? The simple fact is, so I'm a volunteer firefighter, and one of the things we talk about in firefighting is that this kind of rule of five. So you have five firefighters to one deputy captain, 5 deputy captains, 1 group captain. The whole point is that people can only manage a small number of things in their short-term memory in parallel, 5 or 6 different things. The simple reality is, as you get more information, our ability as human beings to make decisions becomes less and less based on that information. The more variety, velocity, and volume of information, our ability to make decisions gets worse. But the reality is, in artificial intelligence, the more information you give the AI, the more variety, velocity, and volume, the better it gets at making decisions. The other challenges you have with human decision making is that we have a lot of what we refer to as cognitive biases. We're essentially lazy decision makers. We take shortcuts when we make decisions. We don't necessarily always make the best decisions, and we don't necessarily optimize across all the different options. One very famous theoretical research paper, research concept called prospect theory, which was developed a few years ago, was around a researcher who identified that human beings actually don't balance or weigh up all the different options equally. What they do is they look at the deltas or the changes in terms of where they're at now versus what's going to happen when they make a decision. This has led to other corollaries. For example, things like we tend to value something more if we have it as opposed to if someone else has it. There's lots of cognitive heuristics or shortcuts that we take as human beings to make decisions. There's just a lot of literature and research around how in various scenarios human beings don't necessarily always make the best decisions. And as I said, we're lazy decision makers. The issue is that more often than not, if a person's presented with the option of either making a better decision or making a quicker decision, we'll typically take making a quicker decision, which infers that we are lazy in terms of how we make decisions. And as I said, the more volume, velocity, and variety of data that we have, the better that artificial intelligence gets at actually making predictions and modeling reality. And this improvements in terms of AI, and that means that we need to, the more and more data we have, the less we necessarily have to understand about the underlying way things function in order to be able. But there are definitely a lot of disadvantages to machine learning and artificial intelligence. This is concept of training data bias. As I said, if we as human beings are biased and we use supervised learning to train an artificial intelligence, then we will transfer that bias to that AI. There are stories of people in the US, for example, using machine vision. There's a very famous story of a researcher in the US who was using machine vision working on a machine vision project, and she got very frustrated because the tool set kept, the machine vision tool kept saying that she was an ape. The reality of it was the tool set had been trained on white men, and she was an African American female. That's why the tool set couldn't predict actually who she was. And that's an example where if you feed in the wrong data, the machine's going to make the wrong conclusion. If you're the person supervising that learning and you're giving them that data, then it's going to, you're going to set up an incorrect model. There's also this issue of what we refer to as a negative feedback loop, where if you're using AI to predict something's going to happen, and it's using information to predict that happen, and then this happens, becomes sort of self-reinforcing. An example of this was that some of the police forces in the U.S. have been using artificial intelligence to predict where or what streets that they should actually be policing or patrolling, because the AI is being used to predict when crime is going to happen. The challenge is, of course, if you're going to actually start patrolling those particular streets, you will, of course, find more crime. You find more crime, that self-reinforces the fact what the model says. So you have to be careful in terms of that model design. The other issue that you get into in terms of building AI, and this is a challenge with the data scientists, is this whole idea that they sometimes take shortcuts in proxies. If they don't have enough data to actually build an effective model, then they use other information that they do have, assuming that it is a good proxy for what's going on in reality. Many times that's not the case. The other challenge with artificial intelligence is it's quite often opaque. People don't understand it, and particularly in terms of tool sets like that involve deep learning, where the models are so super complex. Human beings can't even understand the models. So there's a lot of research going on to actually understand these machine learning models. And so it's this opacity that can be challenged, because you know that the model is very effective at making a prediction or making a recommendation, but you don't know why it makes that recommendation. And just like minimizing feature engineering is a benefit of AI, it's also a disadvantage, because it means that people can build models without actually understanding the underlying reality and make assumptions and make predictions without actually basing that on actual, understanding why it's doing that, which is a challenge. There's been so many issues and concerns with regards to AI. There's been quite a few books written around the topic. If you want a really interesting book to read, there's one by Cathy O'Neil called Weapons of Math Destruction. I'd highly recommend it. Basically, Cathy goes through and gives a number of different examples based on her experience as a PhD doctor who was doing basically building machine learning models for the finance industry and other industries, of how machine learning has been, or artificial intelligence has been used incorrectly. So it's an interesting book to read. There are several different types of machine learning that you can consider. When people talk about machine learning, there's no one type of artificial intelligence in machine learning. There's many. There's what they refer to as unsupervised learning. This is the idea where you're looking for patterns in the data. The human being's not supervising it. The tools and techniques are simply looking for patterns. There's this concept of supervised learning, and this is probably the most common concept. This is where you're actually putting data in for inputs, you're getting data for the outputs, and you're building a model that represents reality. People are supervising. The term supervised learning comes from the fact that the human being is actually supervising, building the model, supervising the AI in terms of what it learns about reality. And the last one, which is becoming more popular in the last few years and is quite interesting, is this concept of reinforcement learning. This is the idea that the AI actually essentially teaches itself. There's been some very famous examples in the last few years of using reinforcement learning. There was an organization that built a reinforcement or an AI to predict or to play the Chinese game of Go. They did a project where they basically had 1,000 people play the game of Go. They then trained an AI using supervised learning on that game of Go. They then used reinforcement learning to actually build an AI to play the game of Go. And what was interesting is the supervised learning AI beat the human people who were playing Go 1,000 times more. Whereas the reinforcement learning AI was 1,000 times more effective than the supervised learning AI. And this was because the reinforcement learning AI actually came up with new strategies and new concepts that the human masters hadn't thought of. Remember, supervised learning is really, in a sense, only as good as the human beings that train it and how they train it. So reinforcement learning is this concept of the AI teaching itself. Here's another chart that I built that basically gives you an idea of how the different types of machine learning or artificial intelligence. As I said, there's the general concept of machine learning, then there's the sort of general types of what they refer to as supervised learning, unsupervised learning, and then reinforcement learning, right? In terms of supervised learning, there's what they refer to as regression. For those of you who've had some experience in statistics, this is the idea of building a model that actually predicts an output versus the various inputs, and it's a continuous process. You can use various techniques to do that. And then there's this issue of classification. Classification can be used in a variety of ways. For example, identifying identifying a photograph as an actual person, or taking photographs and splitting them out between cats and dogs, or identifying just anything, sorting things out, right? These are this idea of classification. And then you have this unsupervised learning, this concept of clustering, where you're basically trying to find clusters or similar things or themes. I'm working on a project right now where we're looking at websites and looking at what people are talking about on websites and identifying those in the themes. So that's a form of unsupervised learning. And then, as I said, reinforcement learning. This is this whole idea that you're actually the AI is teaching itself. The term reinforcement learning comes from this concept. I don't know if you've ever heard the story of Pavlov's dog, where basically Pavlov would feed the dog and ring the bell, and over the course of time he trained the dog so that it would actually bark or salivate when he rung the bell without actually giving it the food. So that's actually training it. And in reinforcement learning, this whole idea of how the AI teaches itself, it gets very good at actually understanding when to exploit its environment or exploit what it's learned to optimize a process versus actually explore to figure out how it can improve a process. So this is reinforcement learning, where the AI teaches itself. Under unsupervised learning, you also have this concept of anomaly detection. For example, it's used in IT security to identify when you have an intruder come in or identify something that doesn't belong. Under the idea of classification, we talked about neural networks, which are machine learning algorithms based on the human brain. And the idea of deep learning are very, very complex neural networks. There are then several sort of more common types of neural networks underneath that. Multi-layer perceptron is sort of the common one. You can see a little bit of a diagram there that's used in a number of different things. Convolutional neural networks is a technology or a type of neural network that was developed in the last few years. It's really good at, for example, text analysis or photographs. And the reason why CNN is very good at a photograph is because, or reading images, is because it not only takes information about the individual pixels, but their relationship between adjacent pixels. So it's it's really, really good at identifying relationships within a photograph. Recurrent neural networks are very popular in terms of text analysis and also forecasting, for example, forecasting financial returns and these kinds of that you can use. Anyways, the point of showing you that slide is to just identify the fact that there are a variety of different types of machine learning or artificial intelligence. There is no one method or tool. So if a vendor actually says to you that they're really good in AI, you should ask what type of AI, how are they using it, what's the actual application. So there are a few AI planning assumptions that I think people should make. The first one is there's no one size fits all in terms of artificial intelligence or machine learning. There are actually a wide variety of tools and techniques. No one consultancy or software vendor is going to be really, really good in all these techniques. They're going to have their own specialties, right? As I said, not all vendors are good at all types of AI. Because there's different types of AI for different applications, this is one of the reasons why general AI is so far into the future, but narrow AI is here now, because the mathematics that you use, for example, to read a photograph is different from the mathematics that you would use, for example, to interpret human text or human speech recognition. There is no one sort of universal artificial intelligence for all tool sets. Often, data scientists have to experiment with multiple different types of models before finding one that works for a specific situation. And even after they've found the best model, often there is a lot of adjustment required called hyperparameter tuning before the AI works optimally. And this often has to be maintained ongoing. So these AI models are not sort of build or set it and forget. Most of the effort in building a good AI solution actually comes in data preparation. If you have good data, then you'll have a good AI. If you have challenges with the data or semantic issues or whatever, then your artificial intelligence tool is not going to be very effective. And whilst there are tools and tactics that the data scientists can use efficiently to find the right solution, this can, to the untrained observers, seem more like art than science. But there is a process that they can go through to systematically find the best tool and technique for the particular problem that you want to solve. Finally, using AI effectively means that the data scientists or organizations, subject matter experts, need to work closely together to get the best results. I've seen a lot of AI projects go off the rails and not produce the desired results simply because the data science is just left onto their own devices, and you don't actually have an organizational subject matter expert who actually understands the process that you're trying to build the AI for and can provide feedback on whether it's being effective. Anyways, that's the end of my presentation. Sorry, I've actually gone over a little bit more than 10 minutes, but hopefully you found it interesting. If you have any questions, you can send me an email at david.goat@sydney.edu.au, or you can find me on LinkedIn and connect with me that way. As I said, this is the first of the series. There will be 2 more that I will produce in due course. One will be about the risks and challenges with regards to artificial intelligence, and the one after that will be how do you deploy AI in your business. But please do give me feedback if you have any questions, and if there's any other topics that you'd like me to talk about in the future.